My name is Alexander, TED/69/19, and I will be sharing the experiences that I was able to learn through the virtual trip that I was able to go through it. And in this video, I am going to share my experience of the virtual trip 2, that is comprising of computer and the specialization area, which is building and civil technology. And in the first part of the trip, I'm going to share about the computer part, of which we are going to begin with the Scada. Scada is an acronym that stands for Supervisory Control and Data Acquisition. Scada refers to a system that collects data from various sensors at a factory plant or in a remote control, and then sends this data to a central computer, which then manages and controls this data. Scada is key element in critical infrastructure control. This system consists of a number of remote terminal units collecting field data connected to a master station via a communication system. And so the objectives of Scada are as follows. The first one is monitoring. It continuously monitors parameters of voltage, current, and other parameters. The second one is measurement. It measures variables for processing. The third objective is data acquisition. It allows frequent acquisition of data through the RTUs and data loggers. The function of Scada are as follows. Scada is used by manufacturers across numerous industries and applications to remotely monitor and automate the control of industrial process and machine. Scada system accomplish this function by integrating with networks, PLCs, RTUs, sensors and machines to collect, analyze, and translate, also display real-time data. The first function is data acquisition. Scada system acquire machine data through network devices and sensors collected to a PLC or an RTU system. These devices and sensors measure parameters such as temperature, speed, pressure, or weight. The data is sent to a PLC or RTU, where it is translated comprehensively and actionable information. The second function is control. Automated process control based on defined set points in another Scada. Scada system can be programmed to perform certain control decisions based on parameters received from connected sensors. For example, if Scada detects an abnormal condition in the process, such as power loss to a machine, and also detects an alarm that the machine backs up battery, power doesn't have charge, the Scada system could perform a control function to automatically turn on a generator to restore the power. The third thing is data communication. Scada system may be used wired or wireless communication technology, as well as different communication protocol to transmit data between machine and operators. And the next thing that we are going to see is the features of Scada. The first feature is the control feature. The main aim of Scada system is to establish the control of different machines of ground level from the main control center. The second feature is the real-time or the historical trend. It is useful feature of Scada. The trends are essential for industrial automation system. Scada system is capable to restore real-time data from fields, retrieve historical data, and graphically present them. And the third feature is the alarm handling. An alarm system is a system designed to direct the attention of the operator to significant aspect of the current state of the plant. Scada can perform this task with high accuracy. And the fourth feature is the report generation. Scada provides a functionality of a report. The user has to prepare a format in which they want a report. It has also a functionality that user can generate a report manually at a given time. And the next part of the thing that we are going to look at is the Industrial Internet of Things, that is the IoT. Industrial Internet of Things refers to the application of IoT technology in industrial settings, especially with respect to instrumentation and control of sensors and devices that engage cloud technologies. IoT is sometimes called the fourth wave of industrial revolution or Industry 4.0. The following are some of the common uses for IoT. It is used in the smart manufacturing. It is also used in the power grid, used in smart cities. It is connected to logistics, also used in smart digital supply chain. And the importance of IoT are as follows. It helps people to live and work smarter as well as to gain complete control over their lives. IoT provides business with a real-time look into how their system really works, delivering insight into everything from the performance of machine to supply chain and logistics operation. It enables the company to automate, process, and reduce labor costs. It enables also the companies to process and help in reduction of the workloads. Edge computing is an information technology architecture that enables data handling analysis and management at periphery of the network, as close as to the source of the equipment as possible without depending on a central network. Edge computing is important to the industrial IoT space because processing data locally at edge offers many advantages over centralized computing. Reason why edge computing is used in IoT application. It allows greater scalability and also its architecture allows for faster response time. And some of the application and solution of the industrial Internet of Things are as follows. First is use of autonomous vehicles. The transport of components to the plant or product to the warehouse can be done by autonomous vehicles that are able to move from one side of the factory to the other by detecting obstacles. Optimization of machine performance is the second. An inactive machine represents a loss of revenue. Thanks to sensors and data processing, it is possible now to optimize machine utilization, time inside a manufacturing plant. And the third one is reduction of human errors. Human operators will continue to be essential for many tasks in the industry, but the tools they use will be connected to the system to save time and avoid errors. And the third one is the improvement in logistics and distribution. Stored product incorporates sensors that provide real-time data on their location and even on their temperature and surrounding conditions, which will be particularly useful during, for example, the distribution of the COVID-19 vaccine is one of the things that was able to gain improvement through the use of IoT. And those are some of the experiences that I was able to gain through the computing part of the virtual trip. And the next part now that I want us to look is the specialization area, which is the building and civil technology. And in the specialization area, I was able to learn about the cement manufacturing process and also the Proctor test. And we are going to begin with the first part, which is the cement manufacturing process. And I will be able to highlight some of the important stages of the cement manufacturing process. The first one is stage one, which is the extraction of raw materials. The raw materials are the ingredients needed for cement production, include limestone, sand, and clay. The ore rock is quarried and crushed into small pieces. In stage two, it undergoes heating As the powdered mixture enters the kiln rotary, it is heated and composed at about 1400 degrees Celsius to 1500 degrees Celsius, which is the principal stage of cement production. The third stage is the cooling and grinding. Clinkers are rapidly cooled down through pass in air from 2000 degrees Celsius to about 100 degrees Celsius to 200 degrees Celsius. Also, additives are added at this stage where they combine with clinkers to be ground in order to produce the desired cement. The stage 4 is the cement storage. The cement is stored in silos over thousands of tons that may be internally divided to different sections with the different types of cement. And the next stage is the quality control. It is essential and it is an important stage in the cement manufacturing process as the cement is sampled and chemical and physical analysis are performed as well as strength tests on standard mortar in order to satisfy its level of quality. And the last stage is the packing. Cement is conveyed from grinding mill to silos where it is packed in 50 to 20 kg bags. Most of the product is shipped in bulk quantities by trucks, train, or ship, and only small amount is packed for customers who need in small quantities. And in the second part now of the specialization area through the virtual trip is the Proctor Compaction test, and that is what we are going to look at now. Proctor Compaction test is a laboratory method of experimentally determining the optimal moisture content at which a given soil will become the most dense and achieve maximum dry density. It is important to have the type of soil with the greatest shear strength. Better strength will be achieved by compaction. The fundamentals of compaction were first time presented by R. Proctor in 1933. In his honor, the standard laboratory compaction test which is developed is commonly called the standard Proctor test. According to Proctor, the compaction of soil mass is dependent in the following four factors. The first one is the soil type, the second one is the moisture content, and the third one is the compactive effort. The fourth one and the last is the dry density. And therefore, the materials needed for the standard Proctor test are as follows. We have the brush, we have the compaction rammer, we have the mold assembly. The third one is the coarse-grained soil sample. Also, there is need of a 2-tin can for moisture content. And the following is the procedure. The first procedure is record the width of the metal fan and mold assembly. The second one is pass enough of the prepared soil through the number of 4 sieves to yield approximately 6 to 7 pounds of 4 materials. The third one, you have to cover the sieve and shake to remove the unwanted large artifice. The fourth one, in the procedure, you have to place the prepared soil in a large metal fan and add water accordingly. Prepare at least 4 specimens having water content, such as the bracket estimates the optimum water content. And the sixth procedure, you have to select water content for the rest of the specimen to provide at least 2 specimens dry of the optimum and water contains varying at least 2%. And the seventh and the last is compact the specimen in 3 layers. After compaction, each layer should be approximately equal in thickness. Prior compaction, place the loose soil. And that is the experience that I was able to gain through the virtual trip. Thank you so much for watching this video.